In this video, we will learn about Ohm's law, circuits, the different types of circuits, and the overall power they produce. To begin, Ohm's law states that the current I is equal to voltage over resistance. Voltage, or potential difference, can also be denoted by delta V, E, or a capital V. It is a measure of energy per unit charge between 2 points in a circuit and is measured in volts. So in the diagram, we say it's analogous to water pressure because it's what pushes the current through the wire, as well as the drop pushing the water through this pipe. The current, I, is a measure of flow of charge in a circuit. So the measure of water, measure amount of water flowing through, and it is measured in amps, denoted by capital A. Resistance is a measure of how difficult it is for current to flow in a circuit and is measured in ohms. It is analogous to how difficult it is for water to flow. So if the pipe got bigger, resistance would be less because it's very easy for water to flow through a big opening. However, if the pipe were to suddenly get smaller, resistance would increase because it's harder for water to flow through a smaller opening. Important relationships to understand when dealing with Ohm's law is that as current increases, voltage increases and resistance decreases. So the more water pressure, the more water flowing through, which means it's obviously not as hard for the water to get through the pipe. These relationships work in the opposite direction as well. Whereas current decreases, voltage decreases, and resistance increases. Less water pressure creates less amount of water flowing through, which means it's harder for the water to get through. These are important relationships to understand for Ohm's law. Now, when we look at a circuit, it is usually drawn, as we see here, with two lines, the longer line being the positive side of the battery, the shorter side being the negative side. When we think of current, current flows from positive to negative. Therefore, if we wanted to measure the current across the wire, we could use an ammeter, which we see here. An ammeter is placed on the wire, and as the current passes through the ammeter, it measures the amount of current passing through. If we wanted to measure the potential difference for the voltage, we would use a voltmeter, which measures the potential difference across 2 points. So this voltmeter here is attached to 1 and 2 spots and is measuring the potential difference across those 2 points. Now the overall power for a circuit is the rate of energy transferred. To find it, you multiply the current times the voltage. So the overall power of a circuit is analogous to the overall amount of water supplied by the pipes. However, this equation itself gives you power for an overall circuit, the entire circuit. If you want to look at one specific part of the circuit, say a certain resistor, which if it was to be drawn would look like this, we wanted to find the voltage, because what if this resistance has a high value, then that means our voltage would be less and our current would also be less at that point. So you could take the power at a certain resistor and multiply it by the current and potential difference at that specific resistor. Now what if you aren't given the voltage for that resistor? Using Ohm's law, you can rearrange your variables and find that V is equal to I times R, giving you I squared times R that we see here. But what if we don't have I, and we only have the value of the resistor? Or what if we don't have I, but we do have the voltage? We can rearrange again Ohm's law and find that I is equal to V over R, so it would be V squared over R squared times R. Your R's would cancel out and you would get V squared over R. Of course, you can use any of these three equations based on whatever variables you have. So when we think of circuits, we think of two different types of circuits. We have series and parallels. Series, on the left-hand side, has the same amount of current, so remember from positive to negative, has the same amount of current flowing through each resistor because current only has one path to travel through. Therefore, to find the total current in a series circuit, you would just take the total current throughout, because the current at each resistor is equal. To find the resistance, you have to add things up. So if we were to label this as resistor 1, resistor 2, and resistor 3, you would find the total resistance by adding each up. This works because, remember, as mentioned earlier, each resistor has a different voltage and a different current based on how strong this resistor might be. Therefore, we must take into account the change in voltage and change in resistance at each resistor. Voltage also adds up for the same reasons. So if we were to take Ohm's law that we learned earlier, and we know that current is staying the same, as voltage changes, resistance must change. So as V1 changes, R1 must change. As V2 changes, R2 must change. And that is why these equations work for series, because one variable is remaining constant while the other two are changing. If we were to look at parallels, however, we see that the resistors are lined up perpendicularly and parallel to each other. Generally, a current would take the path of least resistance, but in this case, we'll say that all of these resistors are equal. So if the current were to be traveling this way, here it would have to choose to either go straight on or downwards. Because these resistors are equal, the current will split, giving the resistor 1/2 and the rest of the current to continue on with 1/2. And then when we reach this intersection again, it'll split again. So 1/4 will go down and 1/4 will continue on. If we were to then add up each current supply at each resistor, we would get 1/2 plus 1/4 plus 1/4, giving us a total resistance or current. So therefore, the current adds up across each resistor. If we were to look at the resistance, when we take the resistance of a parallel, you take the reciprocals of parallels and add them up. This is because, as mentioned earlier, each resistor specifically has a different current value running through it. And if you remember our ratios from earlier, as current increases, resistance decreases, and vice versa. Therefore, only supplying half of the current through this resistor causes this, with the same voltage from the battery, this resistor will increase in value. This resistor only has 1/4 of the current, so it will be even higher than the original resistor. However, these resistors' values are only increasing to accommodate the amount of lesser current flowing through. Therefore, their overall value of a resistor should be found by adding the reciprocals. The voltage is equal at every single resistor. This works the same in how we used Ohm's law, where I equals V over R. If the current is changing at each resistor and each resistor's value is changing, the V will remain constant. So these are our two sets of equations for the two different types of Let's try to solve a problem. It says consider electric circuits below and find A, the total resistance. Now usually you would be able to just add up all the resistance. However, we have a mixture of parallels and series. So first we're going to simplify the parallel resistors. Using our equations, we find that the total resistance of 3 and 4 is 17.14. We can then redraw the circuit, where this resistor right here represents the resistance of 3 and 4. Now that we have the circuit simplified to straight series, we can add all of our values in to give us a total of 97.14 ohms for the total circuit. Part B asks to find the potential difference across resistor R. 4. Since we know that in a series from our simplified circuit, we see that everything is in a series, so we just need to find the total current. We can do so by using Ohm's law, and for the whole circuit, we'll use the total voltage, 12 given, over the total resistance we saw for in A, to get a total of 0.123 amps. Now to find the total potential difference across resistor 4, we can use potential difference, rearranging Ohm's law, is I times R. The current is the same through each of these resistors, and we solved for the resistance of 3 and 4 in part A, giving us a total voltage of 2.117 volts for resistor 4. Part C asks us to find the total resistance or total current through resistor 2. Resistor 2 is in the series, and we solved for the total current in part B. And when we deal with series, remember current is always constant. So if the total current is 0.123 amps, then the current running through resistor 2 is also 0.123 amps. So here's the work for part A, B, and C. I'm going to delete it to create more room. So part D asks the total power dissipated by the circuit. So using our power equation, we know that the total current is 0.123 amps. And then we are given the total voltage to be 12 volts. So we find our power to be 1.476 watts. Power is always measured in watts. So part E asks for power at a specific resistor 5. Now remember, with the specific resistor, we have to take into account the specific voltage and current at that resistor. So for resistor 5, we know the current because it's in a series, and we also know the value of the resistor. Therefore, we can use the second equation that states I squared times R will give you the total power. So again, the current is 0.123 amps squared times the resistance of 50 ohms, giving us a total power at resistor 5 of 0.756 watts. For the last part, part F, asks us to indicate on the drawing where and how you connect instruments to measure potential difference, so we can use our voltmeter for potential difference across resistor 1 and the current through resistor 3. Indicate the name of each instrument, A or V, so the ammeter or the voltmeter. So using our original circuit, to find the potential difference across resistor 1, we'll go before resistor 1 and after resistor 1. So we would draw it like this and put a V for voltmeter. Now remember, ammeters go on the wire as the current runs through it. So to find the current through resistor 3, we can place our ammeter right before current 3. And once again, here are all our answers, with the drawing being the answer to F.